means you're going to pay a little less than a quarter, basically 24 cents, to use the hair dryer. Hair dryer does actually use a lot of energy, surprisingly, compared to other appliances. If you ever get a chance to search power ratings of common household appliances, hair dryers, even though surprisingly smaller electrical appliance, does actually use a lot of energy. We're going to wrap up the notes here, talking a little bit about circuits, as your lab tomorrow is going to deal with circuits. So you guys are going to be building circuits and doing things like that. But you got to know some terminology in order to do that. So first of all, what's a circuit? A circuit is basically a closed loop of electrical components. So what are electrical components? Usually wires, right? Copper wires conduct electricity, conduct charge, allow current to flow. Power supply or a voltage source, so something like a battery. So we look at a battery. You guys have all heard of batteries before, but the potential difference of a battery, a lot of times a AA or AAA we use commonly are 1.5 volts. They allow for charge to flow, current, through its wires and its components. And another one that's common that we're going to see a lot of and talk a lot about are resistors, and that's a component of the circuit that regulates the amount of current in the circuit. So if we look at the diagrams here on the right side, right here, we have some schematics. These are called schematics. Basically, they're just illustrations of what different things represent, different symbols represent within a diagram representing a circuit. So first one is a DC voltage source, so something like a battery. A lot of times we're going to be using this one. This is a battery. So essentially two parallel lines. One's a little bit shorter than the other one with a little gap in between. That's the most common one. There's also an alternating current voltage source. So something like a wall outlet is represented by the following symbol. That one we are not going to use as often. And then finally, the last one, resistor. It's basically a line, a wire with a squiggle, and then continuing the wire. So that represents a resistor. And resistors are very important in circuits because different electrical components need different currents. So the resistor does exactly what it sounds. It allows for this resistance to be present in the circuit. And if a specific electrical appliance doesn't need a whole lot of current running through it to function, the resistance might be high or it might be low, again, just kind of depending on what it needs. So the resistors allow for that to happen. And a lot of times, if there's too much current running through a circuit, so if a resistor goes bad or there's not enough resistors in a circuit or something like that, then the current is too high, and that can potentially cause a fire. Or a lot of times fuse boxes or circuit breakers, when you hear that a circuit breaker went out or a fuse was blown, a lot of times in a car or even in your house, that means that's actually a safety precaution. That means that there was too much current flowing through the circuit, flowing through your house, flowing through the wires, whatever the case is. Too much current can be dangerous and cause a fire, so that's why circuit breakers and fuses were built and are used today to prevent things like fires and other shortages from happening. So just to wrap up the notes here, I'm on the next page, so go ahead and flip over to the next page. We're not going to go through this right now because I want you guys to figure this out in the lab. But there are series circuits and parallel circuits. So series circuits, just very briefly, are when resistors are in series, so there's only one pathway for charge to flow. So in this little diagram here, we can see that there's a battery. Now it's labeled with a positive and negative, but I actually went ahead and drew a picture here on the side of what a battery, the schematic for a battery might look like. So, for example, charge would flow from the positive terminal. So current flows through the positive, goes through R1, resistor 1, goes through resistor 2, goes through resistor 3, and back into the terminal. So this is an example of a series circuit. So here's a schematic or a diagram of a series circuit, where there's one pathway for charge to flow. The second type of circuit is a parallel circuit. It's a circuit where there are multiple pathways for charge to flow. So same thing, we have our battery, positive terminal. So charge comes out of the positive terminal. Generally, that's the conventional current, we call it. And it actually has options, so it can either turn this way through resistor 1 and come back to the circuit. It can continue going through resistor 2 and come back to the circuit, or it can go through resistor 3 and come back to the circuit. So it has choices, and current actually does split up, and we'll talk about more when we get into that after the lab. I want you guys to, again, investigate these properties and calculate values and things like that. So we're not going to get into the equations here or doing this example, filling out the chart. But again, just so you guys understand, there's two types of circuits. Series, charge flows, it's only got one path to flow through, and parallel, it's got multiple paths to go through. So keep that in mind. So that's going to do it for our notes today. That should be enough to get you guys started on the lab tomorrow, and I will be back tomorrow. So if at any point you want to review these notes, look it over again. It's very important that you understand this going into tomorrow. So please feel free to rewatch this video if you didn't understand something.